So we're going to implement this within the script. We just need to unlink this particular element so it doesn't cause any confusion for us. And then I'm going to proceed and delete all of these inputs. And now the question is, how exactly are we going to accomplish this within the script? Let's see. Here I can choose between the simple script and the advanced script here. I personally prefer the simple script because it already includes several features that make our work much easier. And the advanced script has, well, for now, let's just begin with the simple script. We can then explore the other options later on. And what do we see in simple script? If here we already have some tools, then for each loop was added, meaning for each tool from all the tools present in tool block. It runs them using the run tool function, and the result of that execution is stored in message and result output variables. However, in this particular situation, we don't actually need this loop, but we can definitely leave it there. All it will do is simply launch both the PMAlignTool and the BlobTool. But what we are aiming to achieve is that whenever the PMAlignTool successfully identifies 8, or perhaps even n, of those specific holes, we then intend to apply the BlobTool to every single one of them. Therefore, we will implement a ForEach loop, which means for every individual result that is found, we will process it accordingly. So from tools we choose Cog PMAlignTool 1, results. And what is the type of these results? If we take a look, the results are of type Cog PMAlign results. Okay. Cog PMAlign result. So let's get this done. I really need to arrange this particular thing in this specific way, making sure everything is perfectly aligned and set up just right before we can proceed with the next steps. Because results itself refers to a collection of individual results. You know, most of the time, if a word ends with an S, it signifies that it's plural. So this is essentially a collection of items. And if we want to pull out just a single one from that, then more often than not, the cognex method is quite appropriately named because it represents the singular form. Without the S, it's the actual class. Therefore, in this particular instance, we have Cog PMAlign results. And for each PMAlign result, we store it in PMA result variable. So for each PMA result, which represents a single instance of the entire collection of all the results that we have successfully obtained from the PMAlignTool, we are now going to proceed and execute a specific type of iterative cycle. The variable double xpose will represent the x coordinate that we'll be utilizing specifically for our BlobTool. And then, right there, we're going to assign the value of PMAresult to it. And we will choose PMAresult is actually one of the items that we're currently working with, and we need to call the getPose function. A translation X. That is actually what is written here. Results. These are the results. Then there's the item, but we've already extracted it using that ForEach and PMAresult. This is how it should be. So, and then we call the getPose function on that. And the object that function returns contains the translation x value. And we will do the exact same thing for iPose. The y coordinate for our BlobTools region. And now we need to configure the region for that, for the BlobTool. So this tools, Cog BlobTool 1. We don't actually need to write the keyword this here because it's just a reference to our own internal object of this script, which is of course our Cog tool block simple script. But it's not strictly necessary to include it there. Hey, I just write it that way because it helps me remember things better. Cog PMAlignTool 1, and we want to set up the region. No, sorry. I don't want to set it up for the PMAlignTool, but for the BlobTool region. I'll comment it out because I need to check how it actually looks in that region. I'll compile it so I don't lose any changes, even though there shouldn't be any, but just to be safe. And I'll add terminals so I can see how that region is set up here XY. The way I see this ICOG region, so the region is of type ICOG region, which is actually just an interface, and the object that is inserted here into this interface tag is a cog circle. So I have to rename that ICOG region, or rather cast it to cog circle, so that I can access these variables center X and center Y. So I'll be returning to the script to continue from there, and this is my region. I'm going to take another look right here. A region that is of the type public ICOG region. But an ICOG region doesn't have center X and center Y, because every region can have different properties. So I'll do it by giving it a cog circle, because this is in fact currently the object instance of that particular ICOG region. And then I will proceed to assign the blob region to it as cog circle. What does it do? It tries to insert an object into this variable, an object that BlobTool in its parameter region is holding, and it tries to store it there as a cog circle type. If it succeeds, then this object will be defined as a cog circle. But if it doesn't succeed, then this BlobTool, this blob region will be null, right? So this particular operation will then cast this object into this specific variable for us. So I need to verify that the blob region is not equal to null, because if it were null, it would mean that there could be some other type of region, for example, a polygon. Or there could be a rectangle or something else, and it doesn't have to have those center X and center Y parameters then. It can have something else. Therefore, I'd much rather take the time to confirm this particular aspect in this specific manner, and it's only after that verification process is complete that I will then proceed to configure the center X value for this designated blob region. Now, I have it readily available there, and I will set the X position accordingly. Furthermore, I also need to properly set the center Y, which is the Y position. Okay, so what I went ahead and did was, for this BlobTool, I configured the X and Y coordinates, and this is done for every single result that comes from the PMAlignTool. So for instance, if the PMAlignTool here identifies 8 distinct results, it will consequently adjust the position of this specific blob region 8 separate times. However, that doesn't mean anything yet. I still need to launch this tool so that it can actually perform what it's supposed to do on the image that we've placed into the input. So choosing the BlobTool one and selecting Run function of the tool. This means that, at this moment, the BlobTool will execute, and it will search for blobs on the specific coordinates taken from the whole instance the PMAlignTool found. In order for me to see what this BlobTool is actually doing, I can do the following thing. After every single one of these cycles, I will perform a system sleep operation. System, threading, thread sleep, just so I can clearly see how the whole process is unfolding, and I'll input, for example, 200 milliseconds for the thread to wait. Now, when I compile the script, close it, and run this, I should see the BlobTool processing each found hole. But I have to open it like this to see how that region runs. And now when I hit run, I see 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it ran through. I'll give it another try. It was successful. And also, if I were to provide this input image, I would then see blobs appearing there. I'll make it a little bit bigger. Like this. I see the individual blobs appearing. So this is how we made a cycle that runs through all those holes. They are not sorted, so be careful. They're not ordered as first, second, third, fourth, or vertical first, second, third, fourth. We will do parametrical ordering in next episode. Now, it's just according to how the PMAlignTool finds its results based on the score.